Hi everyone. Today our topic is thermodynamics. Thermodynamics is the branch of physics that deals with the laws of transformation of heat into other forms of energy, such as mechanical, chemical and electrical energy and vice versa. Heat is the form of energy that flows from hot body to cold body due to difference in temperature. Hotness and coldness of body is called temperature. Temperature is the physical quantity that determines the direction of heat flow. Bodies are at same temperature, are said to be in thermal equilibrium with each other. The net exchange of heat between them is zero. It is called zeroth law of thermodynamics. First law of thermodynamics. This law states that if an amount of heat delta Q is supplied to a system, a part of it may increase in internal energy delta U, while the remaining part may be used as external work done, delta W, by the system. Mathematically, delta Q is equal to delta U plus delta W. Delta Q is taken positive when heat enters the system, and negative when it leaves the system. Delta U is positive when temperature of system rises, and negative when temperature of system decreases. Internal energy. The sum of all kinetic and potential energies associated with random motion of atoms of a substance is called internal energy. It is emphasized that the first law of thermodynamics expressed three related ideas in a single mathematician formula: the existence of internal energy, the principle of conservation of energy, the definition of heat as an energy transit. Application of first law of thermodynamics. Isochoric process. The thermodynamics process during which the volume of system remains constant is called isochoric process. For isochoric process, volume is constant. Then work done by the piston is zero. So according to first law of thermodynamics, delta Q is equal to delta U. It means that in isochoric process, amount of heat supplied to gas is converted into its internal energy. Isobaric process. The thermodynamics process during which the pressure is kept constant is called an isobaric process. The heat supplied to a gas is converted into internal energy and work done by the system of gas. The pressure exerted by gas molecules are P is equal to force exerted per unit area. Then work done in isobaric process is equal to P delta phi. Then first law becomes delta Q is equal to delta U plus P delta phi. The heat supplied to a gas is converted into internal energy and work done by the system. Isothermal process. The thermodynamics process which is carried out in such a way that a system undergoes changes but its temperature remains constant is called isothermal process. In isothermal process the temperature is constant, so its change in internal energy is zero, and all of heat is converted into work done by the piston. Then according to first law, delta Q is equal to P delta phi. Adiabatic process. The thermodynamics process during which no heat enters or leaves the system is called adiabatic process. For adiabatic process delta Q is equal to 0. Then change in internal energy is equal to negative of work done. This means that if the system does the work, Then in adiabatic process, the work is done at the cost of internal energy. Second law of thermodynamics. The first law of thermodynamics is a generalization of the law of conservation of energy. The second law of thermodynamics tells us how heat energy can be converted into useful work. Two quoted statements are following. Lord Kelvin statement: it is impossible to construct a heat engine operating continuously in a cycle which takes heat from a heat source at high temperature and performs an equivalent amount of work without rejecting any heat to a heat sink at low temperature. In other words, heat cannot be completely converted into useful work during a complete cycle. Rudolf Clausius statement: it is impossible to cause heat to flow from a cold body to a hot body without expenditure of work. The first law of thermodynamics tells us the equivalence of heat and work. Thanks for watching.